All right, calculus, welcome to your notes video for 126.26. We're back to the mean value theorem, which is section 4.2. The other day we talked about Rolle's theorem, which is a special case of the mean value theorem. In layman's term, the mean value theorem, which you got to use if f of A does not equal f of B. They're not beginning and ending on the same points. Mean value theorem says if I made a straight line from A f of A to B f of B, made a line, of what is it, the quickest possible path at a straight line distance, then there exists some C somewhere, and there's maybe multiple spots where the slope of the tangent line to that point, the rate of change, is going to equal to the overall slope from A f of A to B f of B. So in layman's term, I say that there's some, you're going to call it f prime of C. F prime of C that will equal the overall slope. All right. So Rolle's is a special case of that because the slope is 0. So that's why there exists some point C where the slope is 0. All right, so there exists a C or maybe multiple C's. It could be like right here because the slope's going to be the same, so you're going to have two parallel lines. There exists a C or multiple C's such that at point C, the rate of change at that point is equal to the rate of change of the straight line we can make from those 2 points. All right, so we're going to say find all numbers C that satisfy the conclusion of the mean value theorem. All right, so in years past, this one's been okay. Again, the parabola is not the best one to use. You guys can pick up on a pattern there. But what you do need to figure out is you got to figure out what f of 2, or what f of b, and what f of a are, because they're not going to be equal to each other. So first off, I figure out what f of 0 is and what f of 2 is. I plug it into this original, and I get 3 and 1. So the slope of the line that would go from 0, 1 to 2, 3 would be found like this. It'd be 1. So then I take the derivative of my function, which is 4x minus 3, and I set my derivative equal to the overall slope. Rolle's theorem is you take a derivative, set it equal to 0. Mean value theorem, and that's because the slope is 0. So again, this is all about taking a derivative and setting it equal to the slope of the straight line distance. So f prime of x is 4x minus 3, and I set it equal to 1 because 1 is the slope, and I get x is 1, which happens to be in the middle. Funny how that happens with a parabola, right? All right, so that's why we do cubics and things raised to the fourth and maybe natural log. But folks, going to try not to make a 30-minute video here. So pause this if you need to and have all this written down. All right, so that was 1. Let's talk about number 2 here. All right, let's talk about number 2. F of x is going to be equal to x to the third minus 3x plus 2. My interval is negative 2 to 2. Negative 2 to 2. All right, so first off, I got to figure out what f of 2 is. Plug 2 in for x. I get 4. Then I got to figure out what f of negative 2 is. I plug negative 2 in for x, and I get 0. So slope of the line from 2, 4 to negative 2, 0. Again, this is like a cubic. It's doing something like that, but I'm doing straight line distance, all right? It's going to be 4 minus 0 over 2 minus a negative 2. It's 1 again. All right, so then I take the derivative of my original function. You can put c in there. I'm just going to use that, x. I'm going to get 3x squared minus 3. I'm going to set it equal to the slope, which is 1. Again, why 1? Because the slope is 1. I get 3x squared is equal to 4. X squared is 4 thirds. X is plus or minus root 4 over 3, just a little bit bigger than 1 because my interval is negative 2 to 2. If it was 0 to 2, then I only would include the positive 1. Again, some books will have C. You can say C equals because I'm finding a point C, but you can also say X. All right, so f of x is natural log x. Interesting. My interval is 1 to 4. It's not 0 to 4 because natural log 0 is undefined. All right, so I figure out what's f of 4. What's f of 1? You need to know that natural log 1 is 0. So my slope, natural log 4 minus 0 over 4 minus 1 is natural log 4 over 3, which is an odd slope, but that's what it is. All right, so the derivative of natural log x is 1 over x. So I'm going to set 1 over x, my derivative, equal to my slope. All right, now we're talking. 3 is equal to x natural log 4. I divide both sides by natural log 4. I'm going to get x over, I'm going to get x equals 3 over natural log 4, which type in your calculator is roughly 2.16, which is nicely in that interval. Okay. Nice, nice. All right, pause here, pause here. You will have a little notes assignment coming up. These are great questions for, quick check number 3. These would be great questions. All right. Let's move on here. We have, we're not going to go to, we just need to finish up this section here today. So f of x is 1 over x, and your interval is 1 to 3. F of 3 is 1 over 3. All right, and then f of 1 is 1 over 1. So my slope is 1 over 3 minus 1 over 3 minus 1. Negative 2/3 over 2 is a negative 2/6, which is a negative 1/3. My slope is a negative 1/3. So I'm going to take the derivative of 1 over x, which is x to the negative first, bring it down to power 1 power less. All right, it's negative 1 x to the negative second, which is negative 1 over x squared. So I'm going to take the derivative and set it equal to slope. Notice how both numerators are negative 1. So I can really just say, hey, x squared is 3. Or can divide by negative 1. I can cross multiply. I get x squared is equal to 3. I get the plus or minus the square root of 3, but the negative version will count. So x or c is equal to root 3, which is what? 1.73-ish, which is nicely in that interval. The derivative is equal to the slope. The derivative is equal to the slope, mean value theorem. All right, so f of x, we have this cubic is x to the third plus 2x squared minus x, and I'm on the interval 1 to 2. So f of 2 is 2 to the third plus 2 times 2 squared minus 2, you get 14. F of negative 1 is negative 1 to the third plus 2 times negative 1 squared minus a negative 1. That's going to be 2, so my slope is going to be 14 minus 2 over 2 minus a negative 1. My slope is 4. My slope is 4. So I take my derivative, which is 3x squared plus 4x minus 1, and I set it equal to my slope. All right, folks, let's subtract 4 from both sides. First off, I know you can see the quadratic formula, but I try the AC method. 3 times negative 5 is a negative 15. Can I think of two numbers that multiply to 15 because it's negative differ by 4? 5 and 3, 15 and 1 don't differ by 4. Quadratic formula time, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. 16 plus 60 is 76. That's 2 root 19. All right. I'm going to divide this, and this by 2. My interval is negative 1 to 2, and you'll find that negative 2 minus root 19 is like a negative 6 point something divided by 3. It's like negative 2.1 outside the interval. Whereas here, it is like 0.7 something. Anyway, this is the answer. Not plus or minus, but only the positive version. All right. Those are lovely notes. All right, so then what you will turn into me right away when I see you. I'm hoping those country roads are in okay shape, but if they're not, and we have another one of these on Tuesday, you want to make sure to title this 126. So this is notes assignment, calculus, write your name. This needs to be on a separate sheet of paper, definitely. Might need 2 sheets of paper. We'll see what's coming up here. Needs to be on a separate sheet, though. Find all numbers C that satisfy the conclusion of the mean value theorem. So h of x is 4x to the third minus 8x squared plus 7x minus 2 in the interval. Sometimes it will say on 2 to 5, on 2 to 5. So I need to figure out what h of 5 is and h of 2. H of 5, 333. Goodness. H of 2 is 12. So my slope is 333 minus 12 over 5 minus 2. It's 107, so that's pretty nice. All right, I'm going to take the derivative of this. 12x squared minus 16x plus 7. I take my derivative and I set it equal to my slope. All right, so I'm going to subtract 107 from both sides, and then I notice that all three of those terms are divisible by 4. 3 times a negative 25 is a negative 75. Can you think of two numbers that multiply to 75 and differ by 4? 15 and 5 differ by 10. 25 and 3 differ by 22. 75 and 1 differ by 74. So it's a quadratic formula time. X equals the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. 16 plus 300? Yes, 316. Wow. Which is 4 times 79, and 79 is prime. So 4 plus or minus 2 root 79. Okay, I can divide this, and this by 3. Your interval is 2 to 5, so it's not going to be the negative, because this is going to be just shy of 9. So it's going to be like a negative, like 2.3 something. That's going to be outside. So I divide everything by 2, and I only keep the positive version. This is going to be like 3 points. Oh, there it is, 3.63. Which is nicely in that interval 2 to 5. Nicely in that interval. Okay, here we are. You are video 4 of 5 for me this afternoon, turning into early evening here. So last question here. 2 questions, 5 points. F of x is equal to 3 plus root x in the interval 0 to 4. So what is f of 0? What is f of 4? F of 0 is 3, and f of 4 is 5. So my slope is 5 minus 3 over 4 minus 0. It's 2 over 4, which is 1/2. My slope is 1/2. The derivative of x to the 1/2 would be 1/2 x to the negative 1/2. Put that south. So I take my derivative, and I set it equal to my slope. Notice how the numerators are the same. If you have a statement of equality, the denominators must be the same. 2 root x is 2. Divide by 2, root x is 1. X is 1, which is nicely an interval 0 to 4. All right, folks, we're doing a good job. We have no quiz, right? We have no quiz this week. We're in good shape. This is Yak Math Videos signing out.